Good morning, chemistry students. Here are your Chapter 15, Day 4 notes. And we are going to finish our Chapter 15 outline, covering Section 3, Bonding in Metals. You will probably be very happy because these notes should be quite short. So we're going to start by talking about metallic bonds and metallic properties. Metals are a little bit different, and so that's why we're kind of talking about them separately. Metals consist of closely packed cations and loosely held valence electrons rather than neutral atoms. Okay, so what we're talking about is when you see a piece of metal or something that's made of metal, typically those are going to be metal cations that are packed closely together. And there's going to be loosely held valence electrons around them. The valence electrons of the atoms in a pure metal can be modeled as a sea of electrons. Okay, so what we're talking about here is typically, because these valence electrons are loosely held, we often think of them as a sea of electrons. And this sea of electrons is surrounding these closely packed metal cations. The valence electrons are mobile, right? That means that they are free to move and can drift freely from one part of a metal to another. So, to kind of help you picture it, if you think about like when you're sitting in a classroom, and if you think of the students and the teacher as these metal cations, you're fairly closely packed in a normal school year. Be a little further packed right now during COVID, but during a normal school year, you're pretty closely packed together. These, you would be the metal cations. Then kind of surrounding you and kind of filling the room would be these valence electrons that would sort of be like almost like if we filled the room with water, okay? And it would be kind of in between all of you. And so that's kind of cushioning you, each metal cation from the other, is the fact that there are these free moving valence electrons between all of these metal cations. And they're small. They're sort of like a sea of electrons, so they're able to easily get in between those metal cations. So metallic bonds are forces of attraction between the free-floating valence electrons and the positively charged metal ions. So again, kind of think about that, right? You know that positively charged things like a cation, these metal ions, are going to be attracted to these negatively charged valence electrons. So kind of what's happening here is if you kind of imagine your metal cations sort of having arms, right? They're kind of trying to grab constantly at those valence electrons that are around them. Okay, and they're grabbing those valence electrons, and the metal next to them is trying to grab at those same valence electrons, and so that's what's bonding them together. Okay, so they're all of these metal ions are trying to grab a hold of the same valence electrons that are moving around. And because they're all trying to hold on to those same valence electrons, that's what's bonding them together. So this is what holds the metals together. The fact that all of these metal ions are trying to hold on to the same moving valence electrons that are surrounding them. This accounts for some of the properties of the metals. Remember back in chapter 5, one of the properties that we said was true of metals is that they are good conductors of electric current. Right, basically we said that they conduct electricity. And this is because those electrons can flow freely in the metal. So this is because of that sea of valence electrons that are holding and surrounding these metal ions. Effectively then, what can happen is that electrons can enter a bar of metal at one end and an equal number of electrons will leave that bar at the other end. Kind of the way that I like to kind of think about this and kind of picture it happening is imagine, okay, in a classroom that you have the door to the classroom and then you have the window to the classroom. And like in my room, my window doesn't have a screen on it, so you could go out my window if you needed to, okay? So imagine that between my classroom door and between my window, there are students lined up there, and they're all lined up pretty tightly packed, shoulder to shoulder. Okay, so these are our electrons on our metal bar. They're all together, and they're kind of fairly tightly packed. Everybody's kind of shoulder to shoulder. Well, what's going to happen then if somebody tries to add in and come in my room and add themselves to that line, and they have to get in my room? Well, they're going to push, right? And they're going to push all of those people. And the person by the window, they're going to get pushed out the window and forced to leave, correct? That's kind of what's happening on this electrons and in these metals. Because these electrons are free to move, when you add some electrons on one end of the metal, an equal number of electrons are forced to leave the metal bar on the other end of the metal. And so that's what allows metals to conduct electric current. Another property that we talked about of the metals was that they were ductile. And this meant that they can be drawn into wires. And we also said that metals were malleable, which meant they can be hammered or pressed into shapes. And both the fact that metals are ductile and malleable, both of those properties of metals have to do with that sea of drifting electrons. Because that sea of drifting electrons insulates or protects the metal cations from one another, so the metal cations can slide past one another when pressure is applied. Right? And again, it has to do with that sea of electrons. So again, kind of thinking about in our classroom, right? If you think about, again, normal classrooms sitting in normal desks, right? Students are fairly far apart. And the idea is that if we were a metal, then completely surrounding all those students would be these free-moving valence electrons like a sea of electrons. So like there being water or surrounding us, right? That means technically, right, in a classroom, you could force the students closer together. And there still would be electrons between them, right? There still would be kind of water between them, protecting them. And that's what's happening when you take these metals and you pull them into wires or you hammer them into shapes. Those metal cations are protected from one another because those electrons are constantly moving and they get in between those metal cations. And it allows you then to press those metal cations closer to one another without that metal like breaking apart, without there being repulsions between those metal cations. So again, that's why, because of these sea of drifting electrons, that's why metals are ductile and malleable. So that wraps up our notes for Chapter 15. Your final homework assignment for Chapter 15 is on page 429 to answer questions 15, 17, and 18. Enjoy your day. I will talk to you tomorrow.